All right, review for Unit 1, which was on polynomial functions. We see the topics there, the factor theorem and the remainder theorem. As always, I put a big emphasis on graphing, maybe more so than what the textbook does. But the way I figure, if you get a graph, then it gives you all sorts of things, the intervals of increase and decrease and the intercepts and the minimums and maximums, or at least an idea of where they are, that sort of thing. But after the graphs, we also solved some equations and inequalities. It was our first chance at inequalities, and I think that's an example that we'll see soon. Writing the equations of functions, that's what we've got this example first. It was our second crack at evenness and oddness, even and odd functions, and then applications and rate of change, our second crack at rate of change. So the first example is, given this graph, find the equation of the function. Well, what do I know about it? Well, it starts low and ends low, so I know it's even degree of some sort, right? Starts low and ends low. So how do I get the rest? Probably, you'd guess it's probably degree 4, right? Because it's not a parabola shape, and there's not a whole heck of a lot else going on besides the two zeros. I see one there and one right there, perhaps. So that's kind of hard to see, that one. I think maybe on your picture, it's circled in the right spot there at, I think that's at 1.5 maybe. I'm going to write it as 1.5. And then that allows us to, once we get the x-intercepts, to start thinking about the equation. So the x-intercepts, we have x equals, looks like -3, and x equals maybe positive 1.5 is what I said. And this happens to be, it's one of these ones that doesn't bounce and go straight up. That would be a quadratic root. This one sort of looks like it's going to bounce and then slides through, right? This is a triple root. It behaves like a cubic near the 0 there. So we have then f at x. Then remember, each of these roots goes with a bracket, right? Since this is just a linear one, it's just a linear thing. Notice I've left a little gap there, and I'll come back to that in a second. And then it's weird to have a fraction there, or a decimal, but that's fine. And it's a cube. Remember, this whole thing, this whole question boils down to, remember, there's a stretch factor. I know, since it starts low and ends low, that this stretch factor here has to be negative. I'm going to actually calculate what it is in a little bit, but I know that I need to calculate what this is, so what this value of a is. Remember, this gives you what's called a family of curves, right? Or a family of functions. That's any function that has these as its zeros, are related to each other by a stretch. So how do we actually calculate what this one is? Well, notice that the blinking spider there, has a point -2 and 12.8. And so from there, I can actually calculate what this is. I don't think, this doesn't actually work out very nicely, but for an input of -2, I get an output of 12.8. And it's a that I want to find. So an input of -2, I get an output of 12.8. And I'm going to be as exact as I can here. This is a, this is 1, this is -3.5 cubed, which is some awful number. It's a -47.875. And then how do I get a? I divide by that, and it's not very nice. It doesn't work out nicely. But, oh well. so it doesn't work out very nicely. Negative 0.299. And I wonder if this was rounded up here on the calculator. I'm wondering if that was supposed to be negative 0.3. But anyway, y equals negative 0.299 x plus 3 x minus 1.5 cubed. We're not used to seeing this, and remember, because it's a family of curves, if I wanted to, and I'm not going to worry about the details, but if you knew that this was 2x minus 3, because both of them give you a root of 1.5, that's the same, except for then your stretch factor is going to change a little bit, and probably the book would have something clever like that. And it's pretty tough doing that, but you could. I mean, they have the same. That's the same root. If you prefer that, you'd have a slightly different number stretch factor there, but I'll leave that up to you. Moving on to example 2, which is, I think, a great example. How do we solve these? Solve an inequality. Well, and it came up in other units as well. We solve the related equation, right? Solve the related equation, put the solutions on a number line, then check test point. So I'm going to solve the related equation. How do I solve this? Well, this is the factor theorem, right? I'm going to use the factor theorem here. I'm going to call this f at x, and I'm going to look for f at something, and I'm going to try on my calculator, try x equals whatever to try and make this equal to 0, and eventually we'll get it. There's not too many things we can try, right? We'll only try things that divide into 2, things like 1, minus 1, 2, and minus 2 are the only ones we can try, and I think f at 1 works, I believe. It would be 2 plus 1 minus 5 plus 2, which equals 0. So therefore, x minus 1 is a factor. So then what do I do? Well, now I use long division. And can you use synthetic division if you learned how to do that? Yes, of course you can. That might save you a few minutes. And then remember, the technique is I got to figure out what I multiply so that I make sure that this has to be 2x cubed. So when I subtract, so what does this have to be up here? It's going to be 2x squared, because 2x squared times x is 2x cubed. Then I have to multiply the rest of it to do the same thing. Subtract, watch your signs. And now, do you remember how to do this? I hope so. Bring down the 5x, negative 5x, and then the next term is going to be 3x to get 3x squared minus 3x, and then subtract, and I get negative 2x plus 2. And remember, this has to work out. It has to be 0, otherwise you goof something up. And it's kind of a nice check. We knew that had to be 0. And then I use my grade 10 factoring skills, and however you do that, that's fine. Certainly if you have trouble factoring this, you could use the formula, but I know there's not too many things that this could be, right? This is going to be a 2x and an x here. This is going to be a 2 and 1. I just got to figure out in what order. Well, this isn't going to be a 2 here, otherwise I'd have a common factor. The 2's got to go over here, and it's going to be plus 2 and minus 1. So then I say, therefore, star becomes, in factored form, x minus 1, 2x minus 1, x plus 2 not equals 0. Some people on their unit test stopped here. We're nowhere near done, folks. This is factored, but now we state the solutions, right? And what makes this equal to 0? Well, you could show all the extra work, but it's a half, and this is negative 2. And I'm still not done, because this is an inequality, right? I put the solutions on a number line. There's minus 2. There's a half. And there's 1, and I know it's not to scale. Since this is less than 0, that these are going to be open, they're not going to be filled. And remember, the idea is I can check test points to see whether there's solutions or non-solutions. My favorite one is 0, right? And that would be here, my test point x equals 0. I'm going to try that one. And then the left side and the right side. Notice the left side is 0 plus 0 minus 5, minus 0 plus 2. The left side is 2. The right side is 0. Is the left side less than the right side? The left side less than right side? Nope, it's not. So that means this is not a solution. Good. And then I would test point the other places. Now, we also remembered a shortcut, right? Because we think of this graph. If I think of this graph, its leading coefficient is positive. It is a cubic. So it starts low and ends high, right? Starts low, ends high. And remember the fancy math way to write that. Starting low is x going to negative infinity, y going to negative infinity. That's starting low. And the ending is x goes to positive infinity, y goes to positive infinity, right? Ends high. Starts low, ends high. How does that help me solve my inequality? Well, remember, I'm looking for where this graph, where this function is less than 0, right? Well, here's where it's equal to 0. Up here is where it's greater than 0. So when the function dips below the x-axis, my imaginary x-axis that I put on as my number line, well, here are my solutions. Notice my test point did prove true, and this is also a solution. Now I can write my solution set. So my solution set is these ones. X is less than negative 2, put together with a half is less than x is less than 1. And we could put that in interval notation as well. Don't stop there, folks. Remember, after you factor it, you got to finish this bad boy off. Get all the marks for this one, okay? Factor theorem. I think of a graph, and test points. It's a great example. No chance of one like that being on the exam, is there? And there's no chance at all. Yeah, right. Maybe put a star next to that one. All right, that's it. Next up is Unit 2, Rational Functions and Equations.